These are going to be the review problems at the end of Chapter 6 for chemistry. So we're going to start with number 3. Number 3 says that table salt, which is sodium chloride, melts at a temperature of 1,474 degrees Fahrenheit. And then we are asked, what is that temperature in degrees Celsius? So our equation for degrees Celsius is that degrees Celsius is equal to 5/9 times the Fahrenheit temperature minus 32. Okay, so if we put in the Fahrenheit temperature here, then inside the parentheses, that is 1,142. So degrees C is going to be 5/9 times 1,142. So multiply times 5 and divide by 9. And what you will get is 634 degrees Celsius. And significant figures are okay because this number goes out to the ones place, and so that our answer will also go out to the ones place. Okay, then the next one is number 4. And number 4, we are given a temperature of 40.0 degrees C. And we are asked to convert that to Fahrenheit. So degrees Fahrenheit is 9/5 times degrees C, and then you add 32 to that. Okay, so 9/5 times 40.0. So 9 times 40 divided by 5 is 72. And we'll need to make that 72.0 to get our significant figures, 3 significant figures. And then we will add 32. And the 32 is an absolute number, has an infinite number of significant figures. So then when we add those two together, degrees, it will come out to 104. And again, because we're adding and subtracting, we went out to the tenths place. So our answer should also go out to the tenths place. So degrees Fahrenheit would be 104.0 degrees Fahrenheit. Okay, now we are going to jump ahead to number 14. Actually, let's do 13. We'll do 13 first. So number 13, we are given this equation. Okay, so that's the equation we are given, and all we are asked to do is identify the reactants and the products. So these two would be the reactants, and this and the water would be the products. Okay, now we can go on to number 14. And 14 has A, B, C, D, E, so we will do all of those. 14A, we are told, it said solid zinc reacts with liquid hydrogen monoxide. So hydrogen monochloride. Okay, so that would be hydrogen and monochloride would just be that. Hydrogen monochloride, and it makes solid zinc. And we are told that the zinc is this and chloride. Okay, so let's first look at what the chemical symbol for that would be. So this zinc is a transitional metal, so it can have different charges on it. So this is telling us that its charge is +2. And then if we look at chloride is in group 7A on the periodic chart, so its charge is -1. And this is an ionic compound. It's a metal and a non-metal. So with ionic compounds, we switch the charges. So the 1 will go with the chlorine, with the zinc, and the 2 will go with the chlorine. So this would be ZnCl2. Okay, so it's going to make zinc chloride. And hydrogen, or gaseous hydrogen, it says. Okay, so hydrogen, and you know that hydrogen is a homonuclear diatomic, so it has to be H2. Okay, so that's the equation, and now all we have to do is balance it. So on each side we have zinc, hydrogen, and chloride. So on this side we have 1 zinc, 1 hydrogen, 1 chloride. Over here we have 1 zinc, 2 hydrogens, and 2 chlorides. So we just need to double everything over here. So 2 zincs. The zinc was okay, sorry. So zinc was okay, we don't need to worry about that. We have 2 hydrogens, so if we put a 2 here, that will give us 2 hydrogens. We have 2 chlorines, and adding that 2 there also gives us our 2 chlorines. So now we have 1 zinc, each side has 2 hydrogens, and 2 times 1 is 2 chlorine and Cl2, so we have 2 chlorines on each side. So this is the balanced equation for 14A. Okay, 14B. Okay, so this is the equation, and we need to balance it. So aluminum, iron, and oxygen on each side. So we have 1 aluminum here, and we have 2 there. We have 1 iron, and we have 1 iron, and we have 1 oxygen and 3 oxygens. So since we have 3 oxygens here, let's put a 3 in front of there. So now that we have 3 irons, we have 3 irons and 3 oxygens. So we fix the oxygen. So we have 3 irons and 3 oxygens on each side. Now we have 3 irons over here, and we have 3 irons here and only 1 here, so that's an easy fix. We can just put 3 irons there. So now we have 3 and 3 for the irons. And then if we look at the aluminums, we have 2 aluminums here and only 2 aluminums here and only 1 here. So we can put 2 aluminums there, and now we have 2 on both sides. Okay, 14C. It says calcium reacts with aluminum chloride to make calcium chloride and aluminum. Okay, so calcium is Ca, and that's going to react with aluminum chloride. So aluminum is Al and chloride is Cl. Okay, so the first thing we need to do is figure out what type of compound is that and what is its chemical formula. So aluminum is a metal, and it is in group 3A, so it has a positive 3 charge. And chlorine is a non-metal, it's in group 7A, so it's -1. So we're going to switch the charges, so the Al1 and Cl3. Okay, so that's our aluminum chloride. And then that is going to make calcium chloride. Our product is calcium chloride. And again, we need to, what is the chemical formula for that? Calcium is a metal, and it is in group 2A, so it has a positive 2 charge. Chlorine is a non-metal in group 7A, so it has a -1 charge. Switch the charges, so the 1 goes with the calcium, the 2 goes with the chlorine. Okay, so that's our chemical formula for the calcium chloride, and then you have just aluminum. Okay, so again we have calcium, aluminum, and chloride on each side. Calcium, aluminum, chlorine. Calcium, aluminum, and chlorine. So we have 1 calcium on each side. We have 1 aluminum on each side. We have 3 chlorines here, and we have 2 here. So for this one, we can just look at since the calcium and aluminums are okay at this point, we won't do anything with those. So then we have to get the chlorines to balance. So 3 here and 2 here. So you have to find something that both of those numbers will go into, and that's 6. So we need to get 6 chlorines on each side. So we'll put a 2 here. That gives us 6 chlorines over here. And if we put a 3 here, that gives us 6 chlorines on this side. Okay, so now the chlorines are okay, but now we messed up the aluminums and the calciums, but those are easy fixes. So we have 3 calciums here, so we can just put a 3 here to get our calciums balanced. And we have 2 aluminums here, but again, that's an easy fix. We can put a 2 there. So now we have 2 aluminums on each side. So that is the balanced equation. Okay, 14D. Is H3PO4. Start over a little bit farther. Plus HCl will give us PCl5 plus water. Okay, so we have hydrogen, phosphorus, oxygen, and chlorine on each side, on the product side and on the reactant side. Okay, so hydrogens, we have 4 hydrogens over there, and we have 2 here. Phosphorus, we have 1 on each side. Oxygens, we have 4, and we have 1. And then the chlorines, we have 1 over here, and we have 5 over here. Okay, so I'm going to start with those chlorines, because the only way we can get 5 chlorines on the reactant side is to put a 5 there. Okay, so that gives us 5 chlorines on each side, but it's going to mess with our hydrogen. So now we have 5 plus 3, we have 8 hydrogens on this side. And we only have 2 over here, but so let's put a 4 here. And now we have 8 hydrogens on both sides. Okay, then phosphorus are still okay. We have 1 of each. So then we look at the oxygen, and we have 4 here, and we have 4 here. So I think that's going to be it. Yeah, so now we have, actually wait, so hydrogens we have 5, 6, 7, 8. Yeah, we have 8 hydrogens there. Okay, so that is balanced now. Oxygens, we have 4, 4. Yeah, so that's the balanced equation for that one. Okay, then 14E is H3PO4. Oh, sorry, I'm back on the other one. E is C2H3Cl plus oxygen gas will produce CO2 plus water plus HCl. Okay, so we haven't really looked, in class we didn't look at combustion reactions like this, but it is a combustion reaction because you add oxygen and you end up with water and CO2, and then this is hydrochloric acid. So as long as you add oxygen and end up with carbon dioxide and water, it's a complete combustion reaction. Okay, so let's see what we have here. We have carbons, hydrogens, chlorine, and oxygen on each side. So we have 2 carbons here, we have only 1 here. We have 3 hydrogens, and we have 3 hydrogens. Chlorines, we have 1, and over here we have 1. And then oxygens, we have 2 here, and we have 2, 3 over there. Okay, so let's start by fixing the carbon. So the only way we can fix the carbon is to have 2 carbon dioxide, so that makes our carbon okay. Hydrogens are okay, chlorines are okay, so we just have to deal with the oxygens. So So let's see, we have 4, actually we have 5, so now we have 5 oxygens on this side. Okay, so we have 5 oxygens over there. So what we can do is we can multiply, we can put 5 halves oxygen here. Because 5 halves oxygen times 2 is going to give us our 5 oxygens on that side. However, we don't want to deal with that fraction. So we'll just go across, we'll just multiply everything by 2 across the whole equation. So if we multiply 5 halves times 2, that's going to be 5. And then this gets multiplied by 2. This gets multiplied by 2, and this gets multiplied by 2. So now if we look at these, at what we have 4 carbons on this side, and we have 4 carbons on the product side. 2 times 2 is 4. Hydrogens, we have 6 on this side, 2 times 3, and we have 2 times 2, 2 times 2, which is 4, plus 2 times 1, which is 2 more, so that's 6 of those. Chlorines, we have 2 times 1, so that's 2 on that side, and 2 times 1 is 2. And then our oxygens, we have 5 times 2, so that's 10. And over here we have 4 times 2, which is 8, plus 2 times 1, which is 10. Okay, so that's our balanced equation for that one. Okay, let's go on to number 15. So in number 15, we're asked to do different types of reactions. So the first one says, give the balanced chemical equation for the formation of CaCO3. Okay, so that's going to be our product. So to make that product, we're going to combine calcium plus carbon plus oxygen. You have to remember that oxygen is a homonuclear diatomic, so it's going to be O2, and that's going to produce CaCO3. Okay, so then if we try to balance it, so this is a case, so here we have 2 oxygens and we have 3 oxygens, so let's try to get 6 oxygens on each side. So put a 3 there and put a 2 there. So now we have 6 oxygens on each side. But now we have 2 calciums on this side and only 1 over here, so we can fix that by going like that. And we have 2 carbons over here, and we can fix that by going like that. So 2 calciums plus 2 carbons plus 3 oxygens will form 2, that's actually calcium carbonate. Okay, so that's 15A. 15B asks us to write a decomposition reaction. So we are starting with K2, Cr, which is chromium, and then O4. What's that going to decompose into? It's going to decompose into potassium plus chromium plus oxygen, and oxygen is a homonuclear diatomic. Okay, so then if we look at balancing this, we have 2 potassiums over there, so let's get 2 there. We have 1 chromium, so the chromiums are okay. And then we have 4 oxygens over here, and we can get 4 over here by doing that. So that's the balanced decomposition reaction. Okay, then 15C asks us for the complete combustion of C2H2. Okay, so you need to remember that complete combustion means that we add oxygen, and there is oxygen gas, is a homonuclear diatomic. And you need to remember that in a complete combustion reaction, there's sufficient oxygen that the products that you end up with are CO2 and water. And depending on what you're burning, you may end up with something else as well. So let's look at balancing this. So we have carbons, there are 2 here, there's 1 over here. Hydrogens, we have 2 here and we have 2 there. Oxygens, we have 2 here and we have 3 over here. Okay, so we won't mess, the only one that's not balanced then right now is the oxygen. So actually the carbon, the carbon's not balanced. So let's start with the carbon. So if we put a 2 here, that's going to balance our carbon now. So we have 2 carbons on each side. Hydrogens are still okay. And now we have 5 oxygens on this side. Now that we have 2 carbon dioxides, that's going to give us 5 carbons on the product side. Okay, so, or 5 oxygens on the product side. So again, if we take this and multiply it times 5 halves, so 5 halves times 2 will give us those 5 oxygens on this side. However, we don't want to keep that as a fraction there, so we're going to just multiply across everything by 2. So that will make this 5. Multiply this times 2, that becomes a 4. And multiply this times 2, that becomes a 2. So it's 2 C2H2s plus 5 oxygens will give us 4 carbon dioxides and 2 waters. And now if we look at what we have 4 carbons on this side, and we have 4 carbons on this side. We have 4 hydrogens on this side, and we have 2 times 2, we have 4 hydrogens there. And then if we look at the oxygens, we have 2 times 5, which is 10. And over here we have 2 times 4, which is 8, plus 2 times 1, which is 2 more, and that gives us 10 on both sides. So everything is now balanced. Okay, then lastly, number 16, we're given some chemical reactions and we're asked to state the type of reaction. So the first one is this. Okay, so you should recognize that as a decomposition reaction. Okay, then B, CH4O plus 2 oxygens will give us CO plus 4 water. Okay, so you should recognize right away that this is a combustion reaction because we're adding oxygen. However, instead of ending up with carbon dioxide, we end up with carbon monoxide. So that tells us there's insufficient oxygen in this combustion reaction And so this is an incomplete combustion. Okay, C. Okay, so what type of reaction is this? So here we had the hydrogen was bound on the product side, on the reactant side, the hydrogen was bound to the sulfur. Now the hydrogen is bound to the chlorine. And here the chlorine existed alone, not bound to anything, and now we have the sulfur existing alone. So basically, we just had a one-way switch. The hydrogen went with the chlorine, and the sulfur now exists as a single compound. So that this is a single displacement reaction. The next one is magnesium, a solid magnesium plus nitrogen gas, and we get magnesium nitride, Mg3N2. So you should recognize that as a formation reaction. And then the last one is aluminum chloride plus potassium phosphate Okay, so the aluminum and the chlorine were bound together, and the potassium and the phosphorus. And then on the product side, we have the aluminum and phosphorus and the potassium and the chlorine. So we had a double switch. So that tells us this was a double displacement reaction. Okay, so that is the end of the review problems for the questions, the review questions for chapter 6.